In this video, I've been making a glazing solid area ratio calculator for facades. And this becomes, for a lot of the codes, how much glazing you have determines how performant your building can be, because solid is much more efficient in terms of not emitting heat into the building or heat out of the building, whereas glass is much more difficult to insulate. So I built this little machine here that takes like a stroke dash array, so you can change the thickness, the relative thickness of the glass and these mullions. And actually you can do it quite complicatedly with stroke dash. You can build these kind of syncopated rhythms, which is kind of cool, as long as you have an even number there, because it goes stroke dash, it goes solid window. And you can also change the height of the window, of the sill of the window, so the higher it is. And then what analytics is doing is it's summing all this together, and so you can get a building that looks like this, that is 27% glazing. And if you lower that, to something like this, you get to 33% glazing. So pretty fun. And I actually just want to extend that now with a few parameters, just to show the computational designers amongst you, or if you're in the development firm, just some of the ways you can kind of have fun with this. So I'm just going to add a couple design features to this thing. So the first thing I'm going to add is a color. So if I want to override this facade color, currently this is applying the solid wall usage. So if I go in here and I go to solid wall, I can change the color over here, the appearance. I can make it purple, hit save, and that guy goes purple. But that's not quite what I want. I want more something a bit more at the geometry level. So if I have two of these buildings, I can change the colors and I can get sort of a family of buildings. So let's do that in the flow. And it's super easy. So we want to change a property. That property is color. So let's write a feature property. The property we're going to write is color. And then the value is just going to be an input. So we're going to get an input parameter, and that input is going to be facade color, and the type is going to be a color. The default is going to be, we can leave it at this sort of this browny kind of tan I've got going on here. And then we do this. Yeah. And all stays browny tan. And if I do this, it goes purple. And so now that's the vertical bits. Now we could actually do two colors and say, why don't we do that? And so I have two. So then instead of facade color, let's call this the vertical color. And then let's just copy this whole thing like this. And we'll call this, yeah. So it goes pink when there's an error, and that's because this map is outputting to there. So it's like two complicated maps. So if we delete this, it goes good again. And so we'll call this the, it's called the horizontal color. There we go. So we've got horizontal color and vertical color. And remember, in flow, the Z height of these inputs maps to their input on the menu, which is something that L did, which is just so cool. So if I do this at the top, then the sill height goes to the top. So maybe I'll leave the sill height down where it was. There we go. And I'll change this horizontal color to something a bit darker by default. Actually, make it lighter by default. Yeah, lighter. Cool. Okay, and so now we have this facade color changer. Like that. And then we can go like this. So that's pretty fun. So now we have quite a powerful little facade machine that takes in these colors. It takes in this thing. Something that I could do as well, which I actually want to do, is change the vertical offset. So currently there's a hack that's being happened here. So my solid area, right, because the offset is 0.1, so kind of like by convention set, the offset is 0.1, so the length, the area of the facade in elevation is equal to the area of the facade in plan, divided by 0.1 because length times breadth is area. So if you divide by the breadth, which is 0.1, which is fixed, you get the length of the rectangle, and then you elevate it and you multiply it by the floor to floor or the slab thickness, and you get the elevation area. So that's a hack which enforces 0.1 thickness on all of this stuff. So why don't we move some of this logic to here, and then we can have a variable offset facade, which is going to look like 100 times better. All right, and so where this variable offset facade happens is actually down here. So do this. Okay, so you can see I'm just detangling my spaghetti here. This embedded data here is the offset polygon. And so if I put a reader into it, like this, and click on this, and click on the goggles, you can see that what we get is the offset, and the number 0.1 is this delta. So what I'm going to do is I'm going to write a property on this object, and that object is going to be parameters.delta, and I'm going to get the value, which is going to be an input, and it's going to be a vertical offset, and it is going to be, and the default is going to be 0.2. And if we just plug this in here, you can see it immediately offsets by 0.2. And now I'm going to put that right at the bottom. There we go. And now I can play with this vertical offset. Now, the issue here is you can see my solid area calculations are going haywire. So what I'm going to do is I am going to write another property here to these geometries, which is their depth. And then instead of dividing by 0.1 fixed, I'm just going to have depth, facade depth, and I'm going to divide by facade depth, and it'll be parameterized. Okay, and so the way we do that is we write a property to these. So just write feature property.
Yeah.
And these are the ones which we're offsetting, right? So here's the offset. This is the thick one. And we're going to just write a feature property. The property is going to be facade depth. And the value is going to be equal to the offset, same value, vertical offset. So I should actually probably rename that to facade depth. There we go. And then I can put this back out. Okay, so that's that. Now, because analytics it ignores any feature without a parameter. So because we're going to use in our solid area, we're going to add a component. We're going to look for facade depth, and that we are going to write divide by D, save changes. That is now going to exclude this pink, and I'll show that to you if I can by clicking here, and then I'm cycling. There we go. Okay, so that one there, right, is all red. You see this one here, which this is the solid area of the facade that is in this transom panel under the window, is all red because this does not have a facade depth parameter. So analytics just flicks over it. So we need to write a facade depth parameter to this one as well. So let's write a feature property. Write feature property. And it's going to be facade depth. And the value here is going to be, I think it should just be 0.1. So we will fix this. So we're not going to go infinite variability here. This one is always 0.1. Okay, there we go. And now if we come to the solid area and we cycle back to this guy, right, we can see he's not red anymore, he's black, which means it's good, it's run, and the reason it's run is because facade depth has been good. So everything that comes out of this flow has facade depth in the way that we want it. But now we've upgraded it so that it is far more parametric, and the user can change the depth of these facades as well as their colors, as well as their that's actually it, just the colors and the depths. But looks good. Where's my depth? Facade depth. There we go. And the other thing that I've done, and this is just very subtle but very nice, you see this overlap over here? We are writing a does stack to false to all of this stuff, which means that it just doesn't stack. So in old versions of Giraffe, that was just stack. You'd always end up with like these like aerials sticking up, which are now gone. The sad bit about does stack being false is it just doesn't stack at all. So if you are building a compound building out of this kind of thing, you are going to have to set the base height yourself. So say, for example, I wanted to put this guy there, okay, and then I wanted to pull this bit of the building back and in. Okay, you can see it works. However, the facade doesn't. So what I'll need to do is increase the base height manually, which I think sits in 3D. There it is. And just get that base height to where it needs to be. Once you do this, you realize how nice does stack is as in how good it is that Giraffe does this automatically. There we go. So now we have a compound building and everything's lined up, but we've had to manually adjust the height of the facade, and it's because we've turned the convenience method of force stack off.